Good day, viewers. You are welcome. How to solve these nice exponential equations where we have 2 to the power of x, 3 to the power of x to the power of 2 equals 6. So to solve this, from what we have here, we know that when we substitute at x equals to 1, we get the result, and it really satisfies the solutions, and which is true. And we still have another method, another solution that also satisfies this. And how can we do that? So let's try to consider the first solution I stated, that let's say we write this as 2 to the power of x multiplied by 3 to the power of x squared. So we can write this as 2 multiplied by 3. So when we try to compare this, we have this is 2 to the power 1 and 3 to the power of 1. So when we consider their power, since we have 2 here and we have 2, we know that the value of x here is 1. And also for the second one, which is the base of 3, we have x to the power of 2 equals 1. And by taking the square root of this, we know that the x here is plus or minus 1. But only plus satisfy, so the negative is not the solution. So this is for the first one at x equals to 1. But how can we obtain all the solutions that satisfy this? Because we have 2 real solutions for these questions. Alright, let's try to do that. So if I recall from the second line here, which is 2 to the power of x multiplied by 3 to the power of x squared equals 2 multiplied by 3. Suppose I divide both sides by 2 multiplied by 3. So here we have this cancelled and it remains 1. And also with this, we can also change this form. Since it is division, we can change this form to 2 to the power of x multiplied by 3 to the power of x squared multiplied by 2 to the power of minus 1 multiplied by 3 to the power of minus 1 equals 1. So how we get this? So now we have this base, which is 2 to the power x, and here is 2 to the power of minus 1. So by applying the rule of indices, so which is the product rule, we have 2 to the power of x minus 1 multiplied by 3 to the power of x squared minus 1 equals 1. So then we try to introduce logarithm to both sides, which is the natural logarithm. So by introducing natural logarithm, you have ln of 2 to the power of x minus 1 multiplied by 3 to the power of x squared minus 1 equals ln 1. Then by the properties of logarithm, suppose we have ln of a multiplied by b, so we write it as ln a plus ln b. So let's try to apply it at this stage. We have this as ln 2 to the power of x minus 1 plus ln of 3 to the power of x squared minus 1 equals, so ln 1 is 0. Then by taking the power down, we have this as x minus 1 in parentheses ln 2 plus, also with this one, we have x squared minus 1 in parentheses ln 3 equals 0. So what we do next here is, if this is x minus 1 ln 2 plus, so we write this as difference of 2 squared, which is x minus 1 open bracket x plus 1 ln 3 equals 0. So we have x minus 1 that is common to them. By factoring out x minus 1, we have this as, when we divide this one by x minus 1, it remains ln 2 plus, when we divide this one by x minus 1, it remains x plus 1 ln 3, everything equals 0. So therefore, we let the first one here, which is x minus 1 equals 0, and we get the value of x, which is equals 1, as the first solution we get when we apply the first method. And also to get the other solution, we let ln 2 plus x plus 1 ln 3 equals 0. So by transferring ln 2 to other side, we have x plus 1 ln 3 equals minus ln 2. So then we try to divide both sides by ln 3, and at this point, at this side, we have x plus 1 equals minus ln 2 divided by ln 3. Then we take 1 to other side. So by taking 1 to other side, we have this as x equals, so when 1 come here, it becomes minus 1 minus ln 2 divided by ln 3. And this is the second solution that satisfies this problem. I hope we learned something today. Thanks for watching, and if you are new here to this channel and you find this video interesting, please do well to like, share, and subscribe to our channel for more videos. See you in the next class. Never stop learning. Bye bye.